Hello, welcome. My name's Dave Hicks, and today we're going to talk about acids and bases, strong versus weak. At the end of this, you should be able to define what strong and weak bases are. I'm going to show you some illustrations of the particles that are present in strong and weak acid or base solutions. And then finally, I'm going to talk to you a little bit about understanding what's so important about it being strong or weak, and understanding how the concentration of hydrogen ions in solution depend upon this idea. First of all, some quick definitions. When we use the term strong and weak, we don't necessarily talk about whether the substance is like aggressive, meaning it's going to eat through metal or anything like that. In fact, some of the most dangerous metals, some of the most dangerous acids that we have out there, many times are considered weak acids. So that's not what the definition means. It's not strong and weak like concentrations either. So you can have something that is very concentrated but yet still be a very weak acid. Now what we really mean when scientists and chemists use the term strong or weak acids and bases is we really mean that it has completely dissociated in water if it's strong. And I have some examples of some of the strong acids that are around us normally. Hydrochloric acid, nitric acid, sulfuric acid. These are considered strong acids, and when they're in water, they completely dissociate into their ions. The hydrogen ions leave every one of the anions and are floating around themselves. Weak acids, on the other hand, only partially dissociate. And here's a couple of examples of some weak acids. I have acetic acid here, hydrofluoric acid. Both of these are considered weak acids. In fact, most acids are weak acids. There are only about 7 or so strong acids that are out there. So these ones dissociate completely when they're in water, and then because of that, these ones only dissociate partially when they're in water, and because of that, most of the molecules are left where the hydrogen is still connected to the anion, like you see there. Now bases, same thing. A strong base is something that completely dissociates in water. Most of the ones that end in OH like this are considered strong bases. A weak base only partially dissociates with water. And most of the weak bases that I know of are either organic type bases, which usually end in some type of an amine, like an amino acid. It tells you that there's part of a base in there and an acid. Ammonia is an acid. Or if you see on molecules these NH2s that are on the organic molecules, that's the way you can kind of tell that it is an amine group. All right. So let's take a look at some illustrations here. So I said that a strong acid is something that dissociates completely. So before it's put into water, hydrochloric acid would be like this. It would probably be like a gas or something, and it would look like this. The hydrogen and the chlorine would be stuck together, and it would be an individual molecule. The hydrogen and the chlorine would be sharing electrons between them, and that would be the molecule of hydrochloric acid. But once it gets put into water, it completely dissociates, breaks apart. The hydrogen comes apart from the chlorine. Chlorine with its electronegativity takes the electrons, and the hydrogen's left without any electrons, so I've given it this positive charge, and then they're free to move about on their own. So down here I tried to draw a picture. If we could look inside of an acid and see what does it look like inside of an acid, tried to draw this picture here, and this is what a strong acid might look like. Notice that every one of the particles that's in here is completely separated from each other. They're not bonded together anymore, completely ionized or completely dissociated. Let's switch and talk about a weak acid then. So here's hydrofluoric acid. And again, hydrofluoric acid probably comes as a gas before you put it in water. And once you put it in water, it does dissociate, but not all of the molecules dissociate. In fact, very few of them do. Usually we think of weak acids as dissociating far less than 5%, and some of them even far less than 1% of the molecules themselves actually break apart and dissociate. So again, here's my illustration of my weak acid now, and you'll notice that inside my beaker here, most of the hydrogens and fluorines are still intact, still stuck to one another. I do have this one here that I've drawn that is separated. So most of the molecules are intact. They have not dissociated, and very few of the molecules are dissociated within the solution. Like I said, less than 1% of the molecules actually dissociate when they're in solution. Now here we've been talking about acids. Bases are the same way. So a base would completely separate. The cation and the hydroxide would completely separate from each other, and all of the molecules would be just made out of ions that were free to float around. But a weak base, very few of them would actually be producing any hydroxide ions in there. Now the real importance to this is this, and it has to do with how many hydrogen ions or hydroxide ions, if we're talking about a base, are actually in solution. So for every acid molecule that's in solution that is a weak substance, there are very few hydrogen ions, the acidic part of an acid, or hydroxide ions, the basic part of a base. Very few of those are actually in solution itself. For a strong acid or a strong base, then for every one of these acid molecules, there is one of the hydrogen ions that are floating around in solution. And the hydrogen ions, again, it's what makes an acid an acid. So the more of these molecules I have, as many of these molecules as I have that many hydrogen ions floating around in solution. With a weak acid, for all of these, I have very few of these acidic hydrogen ions floating around in the solution itself. So that's strong versus weak acids and bases. I hope you got something out of that, and I hope I'll see you again next time. Have fun with your chemistry.